In this question, we have tan inverse x, which is equals to x minus x cube upon 3 plus x to the power 5 upon 5 minus x to the power 7 by 7 plus so on. Now moving further, tan inverse x square will equal to x square minus x to the power 6 upon 3 plus x to the power 10 upon 5 minus x to the power 14 upon 7 plus so on. Now integrating from 0 to 1 of tan inverse x square dx. So it will be equal to 0 to 2 of x square minus x to the power 6 upon 3 plus x to the power 10 upon 5 minus x to the power 14 upon 7 plus and so on dx. Using three terms, integrating 0 to 2 tan inverse x dx x square minus, or here we can directly write x to the power 7 upon 21 plus x to the power 11 upon 55. Moving further, we can say if this is equals to, after putting the limits, upper limit minus lower limit, we can write 1 upon 3 minus 1 upon 21 plus 1 upon 65, which is equals to 0.30101989, the value of tan inverse x square dx, integrating from 0 to 1. After that 0 to 2, the value will be this. Now moving further, after finding this value, 4 integration 0 to 1, taking constant value before the integrating part. Now tan inverse x square dx is equals to root 2 ln 3 minus 2 root 2 upon 4 minus pi root 2 minus 1 upon 4. The value will be, after putting this value, this is a logarithmic value, so putting this value we will get 0.9 or 2979026. This is the value of this term. Now moving further, percent relative error will be measured minus real upon real. Measured the value we have calculated minus real value which is given in the question upon real into 100. This is how we will find the percentage. Putting all these value together, we will get 0.2979026 minus 301088989 upon, this is a point in point, so here 0.30100989 into 100. Now what we will get? We will get 1.06154448% of error according to the given question.